In question 6, we're looking at randomly selected students from a college. And so the probability that a random student is female is 55%, and the probability that a random student works for more than 10 hours per week is 62%. And we're given that these two events are independent. And in part A, we want to find a probability. We want to find the probability that a random student is male and works for more than 10 hours per week. All right, so first we'll start off by just writing down what we know. So we're given that the probability that a student is female is 0.55. So assuming here that we're only considering two genders, the probability that a student is male is precisely equal to 1 minus the probability that a student is female, right? Because being male in this scenario is the complement of being female. So 1 minus 0.55 is equal to 0.45. All right, and we're also given that the probability that a student works for more than 10 hours, or I'll just say probability a student works for more than 10 is 62%. And so we are tasked in part A with finding what's the probability that a student is male and works more than 10. So to do this, well, we're going to use an important piece of information. We're going to use the fact that a student being female and a student working for more than 10 hours is independent. Right? So if these two events are independent, that means that these two events are too. So remember, if two events are independent, then we know that the probability of their intersection is just equal to the product of their individual probabilities. So the probability that a student is male and works for more than 10 hours per week is just equal to the product of these two probabilities. So we found that the probability that a student is male is 0.45, and the probability that a student works more than 10 hours is 0.62. And if I plug this into my calculator, 0.45 times 0.62 is 0.279. And that's our final answer for part A. Okay, now in part B, we want to find the probability that a student is male or works for more than 10 hours per week. The key difference between part A and part B is that in part A we wanted the probability of being male and working for more than 10 hours. We wanted the probability of the intersection. Whereas in part B, we want the probability of the union, the probability that you're male or that you work for more than 10. So I want the union. Okay. Well, to do this, all we need to use is a probability axiom that we learned last week. One of the probability axioms that we learned was that the probability of the union of any two events is just equal to the probability of one plus the probability of the other minus the probability of their intersection. This is an important formula of ours. So we're going to use that in this case. So the probability that you're male or that you work more than 10 hours per week is equal to the probability that you're male plus the probability that you work, more than 10 minus the probability of these two events' intersection. Okay, well, we found this probability in the beginning. This is 1 minus the probability of being female. So that's 0.45. This probability that you work more than 10 hours per week was given to us in the problem. It's 0.62. And the probability that you're male and you work more than 10 hours, well, that's precisely what we calculated in part A. And in part A, we found that was 0.279. So if I add up these first two and subtract the last, we plug that into my calculator, I should get 0.791. So there's about an 80% chance that a student is one of these two things, is male or works for more than 10 hours per week, or both. All right, so now let's look at part C. Part C, we want the probability that you're male given that you work for more than 10 hours per week. In other words, I want the conditional probability that you're male given that you work for more than 10 hours per week. Remember, one of our other probability axioms or properties was that for any two events, the conditional probability of A given B is just equal to the probability of their intersection divided by the probability of the second event, B. So we can use that formula here. The probability that you're male, given that you work more than 10 hours per week, is equal to the probability that you're male and you work more than 10 hours divided by the probability that you work more than 10 hours per week. All right, well, remember we calculated this one in part A, and that was 0.279. And the probability that you work more than 10 hours per week was given to us in the problem. That's 0.62. And so if I plug this into my calculator, 0.279 divided by 0.62 is about 0.45. So there's about a 45% chance that a random student is male given that they work more than 10 hours per week. In other words, among students who work 10 hours per week, there's about a 45% chance that a random student from them is male. All right. So let's look at part D. In part D, we want to know, are these two events, male and working for more than 10 hours per week, mutually exclusive? Well, remember, the definition of being mutually exclusive, two events are mutually exclusive if the probability of them happening at the same time, the probability of their intersection, is 0. Because two events that are mutually exclusive can't happen at the same time. So let's look at the probability that you're male. Let's look at the probability of their intersection. In part A, we found this probability that you're male and you work more than 10 hours. And in part A, we found that this probability was 0.279. This is definitely not 0. So these two events are not mutually exclusive, because clearly there's students who are both male and who work more than 10 hours per week.